Hi guys, this is Achut. So we are going to be solving today's LeetCode question, which is least number of unique integers after k removals. We are given an array and a integer k, and we need to remove k elements from the array. After removal of the array, we should have least number of unique integers after removing. Suppose let's say we are given an array equal to 554, and then k equal to 1. That means we need to remove one element. Suppose let's take we remove 5, and then the leftover will be 5 comma 4, and then if I remove 4, then leftover elements is going to be 5 and 5. So if we consider these particular cases, we can do any one of this particular operation. So but what we need is we need the least answer. So for this particular case the answer is going to be 2, and then for this particular case answer is going to be 1. Why? Because the number of unique integers present in the leftover array is 1, and then as we need least, so we are going to this particular case, and then we are going to return answer equal to 1. Yeah, and one more thing, if we observe here is, suppose if we remove the number from the higher frequency, then we got like more integers. Suppose let's take one more case where I have 1 2 2 and then 3 3 3. So let's take the case like k equal to 1, and then k equal to 2, and then k equal to 3, and then k equal to 4, and then k equal to 5. So if we consider these particular cases, let's take k equal to 1. Suppose let's say I remove 1. So the number of unique integers is going to be only 2. So the answer is going to be 2. Suppose let's say I take out this particular 2. Then the number of unique integers is going to be 1, and then 2, and then 3. So the answer is going to be 3. And then if I remove 3, then the number of unique integers is going to be 1, 2, 3. So the answer is going to be 3. So out of these particular cases, if I remove equal to 1, then we get required answer. Required answer. Let's consider the k equal to 2. Suppose let's say for k equal to 2, I remove 1, and then again I remove 2. So after this the number answer is going to be 2. So that is one of the case, and then let's say I remove two elements from here, then also the answer is going to be 2. Suppose let's say I remove two elements from here, then the answer is going to be 3. So the answer when we remove 1 and then 2, then answer will be 2. Why? Because we have only 2 and 3 left. And then for k equal to 3, if I remove 1 and then 2 comma 2, then answer is going to be 1. And then let's say we have 4, then remove 1 comma 2 comma 2 comma 3, then answer is going to be 1. And then k equal to 5, remove 1 2 2 and then 3, and then again 3, and the answer is going to be 1. And k equal to 6, remove all the elements 1 comma 1 comma 1 comma 2 comma 2 comma 3 comma 3 comma 3. So this is 6, then answer is going to be 0. Why? Because there is no element left. Suppose if we consider this particular case, as we are saying the frequency of 1 is less, so we are trying to pick that particular case. Why? Because if we remove less number of elements, then we can take this particular route. Suppose let's say I want answer equal to 2. Suppose to get the answer equal to 2, for the element to for three element to get rid of the three element, I need to remove 3, 3, 3, 3, which is the frequency of 3. So I need to remove three elements, but when I want to get the answer equal to 2, I need to remove only two elements. When I want to get rid of only one, then the frequency which I am going to use is only one. So the minimum removals required is going to what we are going to use. Suppose if the frequency is less for some particular number, then we are going to say that particular case we are trying to remove, and then whatever left will be taken care of. So let's code this up. So let's say, yeah, let's take a vector which contains int and then int, and then let's say we sort the array, and then we are trying to build the vector which is going to be the number and then frequency. So we will do that. So for building the vector, when we start with 0 or the array element is not equal to the previous element, then we are going to say the frequency of this particular case is going to be array of I, and then frequency is going to be 1. So we are trying to take the number, and then again we are trying to take the frequency, and then after this we are going to suppose, let's say if the element is same, the previous and then current element is same, then I am going to say v dot back dot second, we are going to increment the frequency. After that I am going to sort vector based on comparison. So let's write the comparison function, and then it is going to take two vectors which is a, and then there is going to be another pair which is b, and then we are going to sort this based off on the frequency. So a dot second is not equal to b dot second. Then we are going to say return a dot second should be less than or equal to b dot second. Otherwise we are going to say we are going to sort based upon the first number, which is should be less than b dot. So this is just a comparison operator when we are going to swap. So this should be the case which we want, like a dot second should be less than or equal to b dot second. Then after this we need particular answer, so I'm going to take variable answer equal to 0, and then we have k. So let's say current k equal to 0, and then for each case let's go through all the elements which are present in the vector, and then if let's take the frequency of, let's take the total frequency like this. Let's say frequency equal to 0, and then whenever we want to remove this particular element, so we need to consider all the frequencies of the particular element, so which is going to be v of I dot second. So if frequency is less than, let's say if frequency equal to k, then we are going to say whatever the leftover elements are there, then those are the number of uh, integers which are present. Suppose let's say we got till 0. Let's say this is 0 and then 1 and then 2. The size is like 2, but for this case it is going to be the frequency map will be 4 comma 4 comma 1, and then for this one it is going to be 5 comma 2. So we have two elements. Suppose let's say k equal to 1. So we'll be considering this particular element, and then we are going to increment that. If frequency and k are same, then we are going to say n minus 1 v dot size minus I plus 1 is going to be the answer. So minus I minus 1. So this is going to be the answer. Else if frequency is greater than k, then we are going to say this particular number also will be included. So we are going to say v size v dot size minus I, and then if it is less, then it is trying to go through all the elements. So at last we are going to say, suppose let's say at last it is going to be 0. Why? Because we had traversed all the elements, and then actually it might be right here or here it will execute, but we are taking like this. Then yeah, let's try to go through the code again. So we are taking the vector and then we are sorting the array so that we'll get all the integers which are grouped like elements, and then we are maintaining the frequency vector, and then at last we are sorting the array based upon the frequency. After sorting the array based upon frequency, we'll take the each frequency, and if it matches with k, then whatever the elements which are left out will be returned. And then if the frequency is greater than k, then we are going to return with with considering the particular element which we are right now, and then if at last we are going to return 0. So let's run this. If we have any errors, we'll see. Solution error csv dot second. Okay. Top first. Yeah, let's write one more test case. Okay, k is some 8, and then again one more. Let's say 10, and again one more. Let's say here 3, again one more. Let's say 6. Let's run this. Valid test case is not okay. Yeah, let's submit this. Yeah, it's passed. So For this particular question, we were asked just to find the list. So the time complexity for this is going to be n log n. Why? Because we are sorting the array, and then the space complexity is going to be big O of n. Why? Because we are taking one more vector which maintains the frequency as well as the number which we are right now. Yeah, that's all for this video. Thanks for watching the video. Bye.